Hello guys. Welcome to the Evolving Knowledge channel. Do you know what acid is? Or base? How can we define them? If you don't know it, today you will finally understand. Stay tuned. Acids were first recognized as a class of substances that taste sour. Vinegar tastes sour because it is a dilute solution of acetic acid. Citric acid is responsible for the sour taste of a lemon. Bases, sometimes called alkalis, are characterized by their bitter taste and slippery feel. Commercial preparations for unclogging drains are highly basic. The first person to recognize the essential nature of acids and bases was Arrhenius. Based on his experiments with electrolytes, Arrhenius postulated that acids produce hydrogen ions in an aqueous solution, while bases produce hydroxide ions. At the time, the Arrhenius concept of acids and bases was a significant step forward in quantifying acid-base chemistry, but this concept is limited because it applies only to aqueous solutions and allows for only one kind of base, the hydroxide ion. A more general definition of acids and bases was suggested by the Danish chemist Johannes Bronsted and the English chemist Thomas Lowry. In terms of the Bronsted-Lowry model, an acid is a proton donor, and a base is a proton acceptor. A chemical equation that can help understand this concept is gaseous hydrochloric acid when dissolved in water. Each HCl molecule donates a proton to a water molecule and so qualifies as a Bronsted-Lowry acid. The molecule that accepts the proton, in this case, water, is a Bronsted-Lowry base. To understand how water can act as a base, we need to remember that the oxygen of the water molecule has two unshared electron pairs, either of which can form a covalent bond with the hydrogen ion. Note that the proton is transferred from the HCl molecule to the water molecule to form the hydronium ion. The general reaction that occurs when an acid is dissolved in water can best be represented as this equation, a generic acid reacting with water. The conjugate base is everything that remains of the acid molecule after a proton is lost. The conjugate acid is formed when the proton is transferred to the base. A conjugate acid-base pair consists of two substances related to each other by the donating and accepting a single proton. The equilibrium expression for the reaction is given for this equation, where Ka is called the acid dissociation constant. This constant is a quantitative measure of the strength of an acid in the solution. The larger the Ka, the stronger the acid and the higher the hydrogen ion concentration at equilibrium. The same approach can be applied for a generic dissociation of a base with water. But in this case, we have the Kb. The larger constant, the strong is the base in an aqueous solution. The pH scale is used to specify the acidity or basicity of an aqueous solution. At 25 degrees Celsius, solutions with a pH less than 7 are acidic, and solutions with a pH greater than 7 are alkaline. This is the pH of common substances. It starts with battery acid to high values of pH, such as caustic soda. You can pause here to check all substances. I prepared a mind map with concepts we discussed here and that can be downloaded in the description below. We are at the end of another video, but before you go, please like our video and subscribe to our channel. This is very important to us to keep making this educational work. Thanks for watching and see you soon. Bye.